students, I am Ekta. Today we are going to learn probability. Students, let's recall what we have studied in the 9th class. What is probability? Probability is a fundamental concept in mathematics and statistics. It is a numerical value that represents the chance of an event occurring and its value lies between 0 and 1. What are random experiments? Random experiments are those experiments whose results are known in advance, but the actual result is not known. For example, if we flip a coin, we know the result will be head or tail, but exactly we don't know which side of the coin will be turning up at that point in time. What is a trial? Conducting random experiments is called a trial. What is sample space? Sample space is the set of all outcomes of an experiment. For example, if we roll a dice, the possible outcomes can be S is equal to 1, 2, 3, 4, 5, 6. What are events? An event is the subset of the sample space. Empirical probability, also known as the experimental approach, is based on actual experiments or data collected from experiments or real-world events or past data. The formula for empirical probability is P of E is equal to number of times an event occurs by total number of trials. Learning outcomes. After the completion of this lesson, you will be able to learn. Understand classical probability. Differentiate the classical and empirical probability. Apply the classical probability approach to solve problems. Keywords. Probability, random experiments, sample space, events, outcomes, sure events, impossible events, classical approach, empirical approach. Students, in this session, we will learn about classical probability. Classical probability is also known as the theoretical approach, which assumes that all outcomes in a sample space are equally likely. The classical probability of an event A is calculated as P of A is equal to number of favorable outcomes for event A by total number of possible outcomes. Now, we will see the examples related to classical probability. Example 1. A box contains 7 yellow balls, 7 red balls, 1 black ball and 1 white ball. What is the probability of getting a red ball when picked at random? Solution. Given Number of red balls is equal to 7. Number of yellow balls is equal to 7. Number of black balls is equal to 1. Number of white balls is equal to 1. Total number of balls is equal to 7 plus 7 plus 1 plus 1 is equal to 16. Event of A is equal to getting a red ball. P of A is equal to total number of red balls by total number of balls in the box. P of A is equal to 7 by 16. Now we will try to solve another example. Example 2. A box of 20 bulbs contain 4 defective ones. One bulb is selected at random from the box. What is the probability that this bulb is non-defective? Note, orange bulbs are defective and white bulbs are non-defective. Solution. Given total number of bulbs is equal to 20. Number of defective bulbs is equal to 4. Number of non-defective bulbs is equal to 20 minus 4 is equal to 16. Event of A is equal to selected bulb is non-defective. P of A is equal to number of non-defective bulbs by total number of bulbs. P of A is equal to 16 by 20 is equal to 4 by 5. Now we will get familiar with dice. When a dice is rolled, the total number of outcomes are 6. Those are 1, 2, 3, 4, 5, 6. And we can get any one of them as we roll the dice. Now, we will try to solve an example related to dice. Example 1. A fair 6-sided dice is rolled. What is the probability of getting an odd number? Solution. Given number of odd numbers on the dice is equal to 3, 1, 3, 5. Total number of outcomes is equal to 6. Event of A is equal to getting an odd number. P of A is equal to number of odd numbers by total number of outcomes. P of A is equal to 3 by 6 is equal to 1 by 2. Now, we will try to solve an example related to dice. Example 2. A fair six-sided dice is rolled. What is the probability of getting the multiple of 3? Solution. Given multiple of 3 on the dice is equal to 2. That is 3, 6. Total number of outcomes is equal to 6. Event of A is equal to getting a multiple of 3. P of A is equal to multiple of 3 by total number of outcomes. P of A is equal to 2 by 6 is equal to 1 by 3. Now, we will try to solve some more examples related to dice. The image shown is the sample space, that is, total number of outcomes when 2 dice are rolled. Total number of outcomes when 2 dice rolled is equal to 6 into 6 is equal to 36. The figure shows the total number of possible outcomes when 2 dice are rolled. Now, we will try a problem. Example 1. When 2 dice are rolled, what is the probability of getting 2 even numbers? Solution. Given total number of outcomes is equal to 36. From the figure, select only those outcomes which are having 2 even numbers. Total number of favorable outcomes is equal to 9. 2, 2, 2, 4, 2, 6, 4, 2, 4, 4, 4, 6, 6, 2, 6, 4, 6, 6. Event of A is equal to getting 2 even numbers. P of A is equal to total number of favorable outcomes by total number of outcomes. P of A is equal to 9 by 36 is equal to 1 by 4. Now, we will try another example. Example 2. When 2 dice are rolled, what is the probability of getting the sum as 9? Solution. Given total number of outcomes is equal to 36. From the above figure, we need to select those outcomes whose sum is 9. Total number of favorable outcomes is equal to 4, 6,3, 4,5, 5,4, 3,6. Event of A is equal to getting sum as 9. P of A is equal to total number of favorable outcomes by total number of outcomes. P of A is equal to 4 by 36 is equal to 1 by 9. Students, let us summarize what we have learned. Summary of the lesson. Random experiments are those whose results are known in advance but actual results are not known. Sample space is the set of all possible outcomes of the experiment. Event is the subset of the sample space. The numerical value of probability lies between 0 and 1. The sum of the probabilities of all the elementary events of an experiment is 1. The total number of possible outcomes when one die is rolled is equal to 6. The total number of possible outcomes when 2 dice are rolled is equal to 36. Classical probability, also known as the theoretical approach, assumes that all outcomes in a sample space are equally likely. The classical probability of an event E is calculated as P of E is equal to number of favorable outcomes for event A by total number of possible outcomes. Thanks for watching this video.